Hello dear students, welcome to today's lecture. So today we are going to discuss about random variable. So we all know what is variable. What is variable? Variable is a characteristic that varies from person to person, object to object, phenomenon to phenomenon. For example, height is a variable because it varies from person to person. So next one is random variable. So what is random variable? Random variable is a variable that takes on numerical values as a result of a random experiment. That means outcomes from the random experiment are the values for random variable. So for variable we can consider either qualitative or quantitative outcomes. But for random variable, see here we can only consider the numerical values. So what are the basic difference between variable and random variable? So as I told you, random variable always takes numerical values, whereas variable can take qualitative values as well as numerical values. And another one is, for random variable, all the possible values must be associated with a probability. For only variable, we don't have anything associated with the probability. So these two are the basic differences between variable and random variable. Now, if we discuss more about random variable, so from the book, the definition of random variable is: a random variable is a real valued function defined over a sample space. So if we consider one real life example, then it will be more clear. Say, if we consider the example as flipping a fair coin 2 times. So then what is the sample space? So we know for any coin there are 2 outcomes, head and tail. So if we flip the coin 2 times, then we know there will be 2 to the power n outcomes. That means 2 squared, that means 4 outcomes. So what are the 4 outcomes? These are the 4 outcomes, right? So head, 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 tail, tail, head, and tail, tail. So again, back to our definition of random variable. See, random variable is a real valued function defined over a sample space. So defined over a sample space. So this is the sample space. Now, if we consider one variable x, which denotes number of heads. So back to the sample space. See here, how many heads we have here? 2 heads. 1 head, 1 head, and no head. That means 0 head. So what are the possible values for x? The values are 2, 1, and 0. So still x is a variable. Now, if we can assign probability for each value of the values of x, then we can say x is a random variable. So if we consider x equals to 1, that means head appears, and if x equals to 0, that means tail appears. So now what are the values for x? X, 0, 1, and 2. Now let's see whether they have their corresponding probabilities. So when x equals to 0, how many outcomes we have as x equals to 0? See, only one outcome, this tail and tail, right? And for the whole sample space, how many outcomes we have? There are 4 outcomes, 1, 2, 3, 4. So from the definition of classical probability, we know probability is the ratio of favorable outcomes and the number of total outcomes. So when x equals to 0, number of favorable outcomes, we have only one outcome, tail and tail. So that's why it is 1. And total outcomes are 4. That's why 4. So when x equals to 0, we can say the probability is 1 over 4. Similarly, when x equals to 1, how many outcomes we are in favor of x equals to 1? See, there are two outcomes, HT and TH. So that's why here we put 2. Number of favorable outcomes are 2. And as usual, total number of outcomes are 4. That's why when x equals to 0, the probability is 2 over 4. Similarly, when x equals to 2, the probability is 1 over 4. So now back to our definition again. It is said that random variable is a real valued function, right? So this is the functional form. See, when x equals to 0, we have the probability 1 by 4. So we can say x comma p of x is the functional form. And see, it is defined over a sample space. So this x is defined over this sample space. Now I hope it is clear that what is random variable, right? Okay. So finally, we can say x is a random variable from this table.